Hey, good morning, everybody. It's been something I've been working on pretty heavily for the last year, particularly with Azure. And that's kind of the perspective today, is actually working with Hadoop technologies in Azure, which we do quite a bit of here at Pragmatic Works. I've talked a little bit about this in some of the SQL Saturdays I've done this year. So this is kind of a furtherance of that. If any of you were able to make it out to see us, well, we appreciate that. So let's get started real quick. I've been doing this a little while anyway, and I think that I've seen a lot of technologies come and go in this time. And so I basically have a background that started out in Unix long before there was a Windows anything, and now and been doing working with the Microsoft product stack for since the early 90s. I think I did a 6.0 engagement with SQL Server, and then went backwards and did a 4.2.1 engagement for someone who just happened to have an earlier edition of SQL Server, and from there on it's been pretty steady with SQL Server. So we want to talk some about that. We want to talk about Azure as a technology resource, particularly with regard to Hadoop and Spark, which is what this is about. Now, I live in the Minneapolis-St. Paul area, so there you have both of those shining cities on the hill there. That means it's, yes, it's cold, and but it's usually comfortable in the summertime. So this is our shining moment, being able to enjoy the weather without having to shovel any snow. So a while back, I started learning Hadoop technologies, and I had good fortune to meet up with Doug Cutting at one point. That's the actual Hadoop toy that it's actually pronounced Hadoop, according to Doug. That was his son's toy that it's named after. Actually, what's fun is when you hold it, it's a homemade toy. It's not something you could buy in a store. So all you crafty people out there, this is a win for you. It looks like it was made out of some kind of cloth that someone had scrapped and made a baby toy, and so that is where the name came from, and many of you probably know that. So I'm at Big SQL on Twitter. A long time ago, I figured out that SQL Server does a lot of things very well and is a great piece of technology, but what it doesn't really do well is scale. So back in the day, we had federation and all those techniques, and eventually we added table partitioning and imitated our big brother Oracle, and learned to grow that way. So now we're kind of running out of that too. SQL Server does many things well, but there comes a point. And so what I try to teach people is how to scale beyond that with using SQL Server as your main data warehouse engine, your OLTP engine, and then using Hadoop as your archive store, for example, is a great combination of all those things. So this is really for anyone interested in Hadoop, Spark, anything to do with the Azure stack in that regard. I've done some Azure SQL Data Warehouse and Azure Data Lake and Data Lake Analytics as well. So, so I think that Microsoft has done a great job investing in these technologies and trying to participate in this area. Anybody that's here that is kind of not in those realms, probably not the right place. You're welcome to stick around, but I don't want to bore anybody that got here thinking this was something else. This is your chance. So we're all just like searching for answers here, right? So there's no one resource to answer all these questions. With me, it becomes sort of a thing of talking to other people or working in groups and and doing some public speaking, I get a chance to talk to people about their problems and patterns and what is exactly it that they're facing with big data. So we're kind of all in that same boat. There's no one single answer that's going to help you with everything. So this isn't a complete guide of anything. This is an hour-long session, so it's not really advanced. It's not a deep dive. It's none of those things. It's just kind of an exploration of what we have out there. We're going to do that here in a minute by setting up our first Spark cluster and going through this. So, having said that, we've done a lot with Azure and Hadoop. HDInsight started out kind of as the, we'll say the kind of entree into big data for Microsoft. It was based on Windows, 2012 essentially, and and by that it was kind of constrained. It did some great things, or has done some great things, in that it's very easy to set it up quickly and push some data onto it and try it out. The downside is it hasn't been very scalable. Like, you couldn't shut off the cluster, things like that. Things that we're not used to in traditional Hadoop. So it's been give and take. There's been some good and some bad. And most of what this topic is about is batch, right? So that's kind of why it was the topic the presentation title is what it is. So it's mostly, when we're talking about this, is very large batch processing. So we'll take a look through this area and take a look at loading data and exploring Apache Spark through the Jupyter notebooks that are provided. And there's some great examples here, and we're not going to go through too much of that, but we will work through the Jupyter notebooks a little bit to give you some idea of what that's about. And you could have guessed by the name that it's based on Python, just by the way the Jupyter's spelled. So some of you probably know all about that. So what is Apache Spark? It's an in-memory framework for Hadoop, really. And the in-memory is a key word there, kind of like we do in-memory OLTP and SQL Server 2014 and above. Everything always happens faster in memory, and that's a big deal. But it's not just that. I mean, when you think about Hadoop, we're also talking about a distributed framework, right? So it's also open source. It's also an Apache top-level project, and that's important because things that are not top-level can be kind of combined in other projects or can disappear. Spark has managed to make its way to the top of that heap, where it is an actual top-level project like Hadoop or many other things. So that means a certain level of it's going to be here a while. So it's pretty much a given. So we take a look at this a little bit. I'm going to move things around on my screen. Give me just a second. We take a look at the overarching diagram. We can kind of get some sense of what's going on here. The pieces that make up this whole thing we call Spark. We have Spark SQL, Spark Streaming, MLib, which is the machine learning library for Spark, GraphX, and Anaconda libraries. These are all these pieces that make up what we think of as Spark. Let's go on further. So Spark is really to help us and this poor gopher tortoise from Florida here figure out which way is the fast way to get things done. Let's see. So it all started with, as all good projects in open source should, with a very deep paper on this problem and presenting this up through RDDs, resilient distributed data sets. And in fact, I think just two young guys and UC Berkeley were responsible for most of this activity, most of this effort. So basically, it basically is using memory and is area thought of as the resilient distributed data sets to kind of get us a framework. And you can search for this paper and find it, or I can provide you a link to it. It's great. It gives you the it's kind of like if you've ever read the Google file system original paper. It's kind of that kind of seminal level, thing that kind of sets the table for a lot of work. Very good, by the way. So here's the problem it's really taking on, is that it's called, what I think of as the MapReduce problem, right? The MapReduce problem is it takes bloody forever to get something to process. There's a lot of front-end load that has to happen. And so I think of the two between something like, SQL Server there on the right with the sports car versus Hadoop there on the left as a train engine. The train engine takes a lot of effort to get those wheels turning, but boy, once it does, look out. And so the Ferrari on the right, they definitely beat that train out of the gate, and they'll do it for quite a while, I'm sure. But sooner or later, that train is going to catch up, and it's going to haul a lot bigger loads than that sports car will ever haul. So they're two different things. They work differently, and they're architected differently. So if you remember back, if most of you have looked at the MapReduce, shuffle, reduce kind of diagram, this is straight from Apache's website. It's just, it comes to the realization that, computers do several things well. One of them is sort things, which is really the fundamental piece of this, and map things. And so this kind of gives you this diagram of how this is all going to work in these 128 megabyte blocks that are up here. Data that are going to be pushed across, sorted, shuffled, and then reduced down into a combined data set over there on the right-hand side. And so we were talking a little bit about the newer MapReduce, which involves Yarn, which is a lot more efficient than the old MapReduce. I won't stay here long, but just know that we're making improvements in these areas, and that it's continuing to move. Yarn was the big thing a couple of years ago. Now the big thing is Spark, and Spark is seeming to replace a big part of what we were getting out of Yarn. So this is the great part of this kind of technology, is that it moves forward on a pretty frequent basis. So let's take a quick break from this. I want to run out to our HDInsight, or our Azure portal. Let's kickstart and have us build our first Hadoop cluster with Spark. So if we basically go new here on the right, and I believe it's under Data and Analytics, we can locate HDInsight down here. We'll go through this dialog real quick, because it's going to take a few minutes to build this for you, and we'll be ready for it by the time this is kind of winding down. I'm actually going to put my initials here in the front so I can find my stuff. We have a lot of people, as you might imagine. So if you've never seen this, I'm in Azure in the new portal, and I'm going to configure this out for you. So here we get to choose the cluster type. Obviously, we're going to go with the Spark one. There's a new one. The R server on Spark preview is out. So if you haven't gotten out, and this is something that you live for, I haven't tried it myself yet, but that's teed up for later this week. So we're going to try the Spark cluster. And I think they quit offering Spark on Windows, which is why you don't see it here. Up till very recently, you could do either one. Obviously, it's defaulting to Premium Edition. We're going to go Standard to save my boss some money. I'm sure he appreciates it. So basically, they're talking about premium storage, and of course, with that, you have premium templates that can be leveraged. So let's just go this way real quick. We'll select this guy. And of course, the next question going to be credentials. I think I'll change that to RG. So I guess I like my name. A lot of times when I'm configuring these things, I don't know how you all work, but I will keep a little tab like this going so that I can remember all the lies I told. So that'll be our password. I'll destroy this cluster shortly after. So SSH username, we're going to kind of get into that here in a few minutes. So we'll just do SSH admin and use the same password. So here, I need to remember that that's what I used and that's what I used for SSH. Strangely, that's the only time you really get to see this thing. So let's see. What are you upset about? You don't like the password. Oh, all right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How about that? Passwords. I think both of them the same, just so we don't have an issue later. All right. Don't ever do it that way. Obviously, generate a real password for a real cluster. This won't be around an hour, so. So data source here. So we're going to let it create a new storage account. I'm going to also, I don't have to do this one. I don't, and it will tell me later on that what it did. And I'll just say container 1. Probably change the location too. I think we're kind of running out of space in East US. Let's go Central. We're in Central time, right? What's the matter with that? Doesn't need to be one. And lowercase letters. Oh well. Rules are for rules. All right, we're not using Active Directory, and that was the next question on that setting. We could though, and that's really an important point. Integration with Active Directory is one of the godsends of some of this. And regular physical clusters, say something like Cloudera, I can always integrate to Active Directory and use Linux to bring that in with PAM and whatnot. So whenever I'm just building something like this just for test, I always cut way down on the sizes of things. I could also cut down back here by trying to choose some other nodes here. I won't today, just for brevity, but I think that we'll go ahead and select and choose their D4, but know that you can change these around. So we're going to have 2 data nodes when this is all done. On the resource group, we'll just create a RG lab. And also pin it to the dashboard so we can easily find it later. If you get this many people together, you can imagine it takes a little bit of effort and time to keep our Azure subscription nice and minty fresh. So let's see. And we can see here deployment started. You can also see the ones I've worked with earlier today and other days that been deleted since. So. Okay, so that's moving along. Let's let that cook for a minute. Go back to our presentation, and then we'll explore the dashboard here in a minute. All right, so moving on. Pig and Hive are probably the two predominant tools that you'll work with in Hadoop. And one of the things that is interesting to note here, Hive has a metastore to keep track of your table definitions. So I'll break for a second to show you what that looks like. So if I define a table in Hive, right, this is the typical definition. Create table if not exists. It's kind of a little different. I think we've recently gotten this language type construct in SQL Server. It's only been in 2016 that we've gotten it. But so that if not exists. So we don't have all that if stuff to try to figure out is the table already there like we do in T-SQL. So what Hive is going to do with this is it persists this. You'll notice that that basically it looks a lot like what you're probably used to. There's some other things I could have said in this. Create external table if not exists. And external means that basically I'm going to manage it. So when I drop the table, don't drop the data. So and that's very useful particularly in this technology where you can leave the giant file behind that you've copied over into the cluster. In the meantime, you can go change the definition of what the table is. And this gives you some idea what you can do. And if you ever wonder what is it I can do in HiveQL DDL, you can go in Apache Hive DDL, and I think you can find the language manual for Hive out here, and it will give you all the things that you can do and the ways they work. If you go past the beginning part, and then create table and all the different wonderful variations. So if you're curious about that, please use this DDL reference. It changes some as Hive changes and gets better. Like as this is noting, we're up to version like 0.313, which little minor point differences in this stuff can mean huge differences in capability. So this kind of gives you some idea of table partitioning, all the other things we can do in Hive. But going back to our example, this is all going to get stored in a database. And a database usually is a choice between when you do a traditional cluster, you choose between MySQL or Postgres. Those are the two I remember. So this is being stored in there. And what the fundamental thing to remember about that is that everything in the bloody world uses Hive's metastore. Pig can use the Hive metastore. There's a whole separate product, open source product called HCatalog that can read Hive's metastore and expose it to other tools. So Hive is kind of central, even though we're not really talking about Hive today. Just know that the underpinnings of a lot of what goes on have a lot to do with Hive, and the reason why is it became, the kind of early tool that everybody used, and the metastore got really strong and really good. And the last thing you want to do is redescribe a table 1,000 different times in its raw format to all these different tools. So that's kind of what the role of Hive is. So like I said, Pig can leverage the same tool set, so it'll use Hive's. Anyway, current slide. So Hive's architecture. Hive is really thought of as originally was sort of thought of as a data warehouse. I know it's not our data warehouse like we think of it, but it was kind of when the original people were involved in this, kind of thought of it that way. So it's really important to look at it kind of from that perspective. So here you can see the Hive metastore, a Hive query language, HQL, the command line interface, CLI, right, and the web UI that we'll also work with, how it interacts with MapReduce jobs, and the overall cluster. So you start to get some sense of how this stuff fits together. So kind of the fundamental notion behind massively parallel processing, particularly in Hadoop, is that, here we have somebody buttering a piece of bread with the butter. So you can move the data to the work, or you can move the work to the data, right? That's the fundamental thought behind a lot of this. It's a very topsy-turvy sort of thing to think of it that way, but that's exactly what we're doing. We're moving the work to the data. And so that means each data node is going to have one or more jobs running on it, and they're going to spin up and try to do the various pieces. So, and so the benefits obviously are we're not moving large amounts of data over the network all the time. We're going to where the data lives and running the job right there. So that's the whole benefit. All right. So HDFS is designed. We originally started out with 64 megabyte block sizes. That can be changed. You'll see it a lot more often these days as 128 megabyte blocks. And we could talk about lots of areas around that, but just know that that's kind of the fundamental idea. FS image is just a table. It contains a map, basically, of nodes to block numbers, and that's stored on the name node. And by default, each block is replicated 3 times. Now, you can change that to 1, which means you'd have no resiliency, which would be a bad idea, or you can change it to 5, which means you would have the block replicated across 5 nodes minimum. So it's very, very much something you can configure. So, and this is kind of what the FS image sort of, and sort of a high level might look like. And the block, it's a block map basically that we're showing here. So MapReduce, the heart of that is, you're taking text strung across multiple blocks in theory. Obviously, this little bit of text about rubber ducky isn't quite big enough to fit across any blocks. I mean, 160 or 120 meg block is probably what they're using at Microsoft. So that's going to take a lot of text. I gave you the Spanish equivalent over on the right, just to be fair. Typically, everything's written in Java. We've talked about the map, shuffle, sort, reduce phases. And it can be bypassed where it's not needed. For example, select star from my table. There's no filter here. So why do any reduce at all? Just go get me all the stuff that's in the table. So it doesn't always mean you have to use MapReduce. All right, let's go check on our cluster here. We're out there baking here. And we're deploying. Awesome. It'll show up here in a minute. Let's go back here. So a minute ago I mentioned the name node and the FS image map. And this is kind of what an actual Hadoop cluster might look like in sort of a logical view. So we have the name node. We have a backup name node 2, and we often will have a client node that will interact with the cluster. And so what's interesting about this is that as these blocks are stored out there and the data is stored, if we lose one of the nodes, the name node can instruct, it can take that node offline and make it unavailable, but it also can, when we bring a brand new node in to replace it, tell its sister nodes, hey, you got a new friend over there, make sure they get this block, and this block. They'll communicate amongst themselves and share the block between them and store that out on the new node. So it's very, very tough and very resilient. I really like how that works. So back to the rubber ducky sort of thing. So we're doing MapReduce the hard way. So, rubber ducky, you're the one, you make, and so forth. So it could be that the name node in this case decides to store block number the word rubber on block 2, on node 2 rather, Ducky is on node 2, and then the next word might be stored on node 1, and so forth. And that's kind of how that works. And then the reduce phase of that, we start coming down to how many times was the word rubber used, how many times was the word Ducky used, and so forth. So we got key value pairs, right? We're all familiar with that kind of idea, I'm sure. Just as an aside, we have other products that are not MapReduce solutions that bypass the whole idea of MapReduce. Impala from Cloudera is one. Presto from Facebook is another. Spark, this is obviously what we're here to talk about. And then a whole bunch of third-party things that don't use MapReduce and therefore are fast. And so kind of give you some idea of that aspect. So originally Hive was developed by Facebook, used heavily in Amazon and Netflix and some of the other big ones. And of course what everybody wanted to avoid was writing a bunch of Java code doing MapReduce, and they wanted a wrapper over the top of that stuff. The MapReduce gets written, it just gets written by Hive. You don't write it. You don't have to write it, I should say. So we have a series of thrift servers when it comes to Hive. Hive Server 1, Hive Server 2, or Hive Server, I should say, in the original one. We've kind of gone through some of this together. So one thing to watch out for around Hive query languages, if you're used to T-SQL, you're used to a very complete, very mature language that's quite capable. But I think we've just recently gotten windowing functions in Hive, for example. We've had those quite a while in T-SQL. So things like that. So don't always assume that because you can do it in T-SQL, you can automatically do it in Hive. Again, use your reference. So, yep, creates some MapReduce code, submits the code to the cluster, and displays the results. I'm just hoping our little cluster gets made out here faster while it's chomping along. All right. We'll keep going. So it's a subset of ANSI92. Doesn't support anything like store procedures. No. It does have a place in its life for functions. Requires a semicolon terminator. And so when you're working with Hive, you're kind of looking at the future of SQL Server. I keep hearing someday Microsoft's going to make us use the semicolon terminator. Well, if you work in Oracle and other languages, Postgres, you're kind of required to use a semicolon anyway. So it's a good habit to get into anyway. Doesn't support transactions in that typical way. Overwrite instead of insert and update is a different keyword than you're probably familiar with. We've only gotten indexes in Hive at a very late stage, so I've probably been out there at this point 2 years, maybe 2 years, maybe 3. It hasn't been long. This is a note about being version aware with Hive. You can kind of see I've taken some of the various pieces here and highlighted them for you. You can see we only had binary data type starting at version 8. We're on 13 right now. Timestamp, same thing. Decimal data type on 11. So these are really something to be aware of is versions and what versions support what. If you're just starting out with Hadoop, chances are pretty good that you're so late to the game that most of the things that you might have run on will probably not be so much an issue. So one other topic, this is about schema and read, right? When we talk about RDBMS systems like SQL Server and Oracle, right off the bat, when we try to write to it, it prevents us from putting in data that don't follow the rules. So it's kind of the direct opposite of that in these technologies, especially Hive. It's schema on read. So basically, the data is only checked when it's read. As it's one thing to keep in mind is that Hive was built by people who wanted the job to succeed. And so if you're, like, say, Yahoo, and your job is to scan the internet every night, find every link and every HTML website and everything, and scan that and bring that data back and store it, failure is not an option. So Hive is kind of built with that in mind. You can do some ridiculously silly things in Hive because it won't force you to be, logical all the time. So be aware of that. That when you're working with it, that it really is, one way or another, it's a trooper. It's going to try and find a way to complete that job. If it can't, it's pretty bad. Anyway, so part of what I want to say in this part on schema on read is that we don't have to know everything there is to know going in, right? Like we're used to traditional OLTP, we have to sit down and design our tables, columns and data types and nullability. All that stuff has to be known going in. What the relationships to other tables are, and all that stuff has to be firmly defined, or should be. This is kind of the opposite. This is where I get this CSV file in every month. Normally I would store it out on my file system. I'm a little bit worried that other people can get to it too easy, so maybe what I could do is put it in Hadoop and store it permanently, and then I can put a Hive table over the top of that when I get around to it, and then anybody could query it if I did. So it's that kind of a thing. It's a different approach from what you're used to. So HCatalog we mentioned earlier. I'll just bypass these areas, but just so you see this diagram, that HCatalog kind of is at the heart of Pig and Hive and the streaming side, and also an important thing is the file formats like sequence files, text files, RC files, ORCs. These are different formats, but HCatalog is kind of at the heart of a lot of these things, so you'll probably become familiar with that. All right, let's go back while we're waiting on this. Let's see how we're doing back here. So hopefully we're getting close here. We'll see. All right. Back to the grind here. So let's current slide. So in Spark, we have this idea of a driver program and a context that talk to the cluster manager. They can also talk directly to the worker nodes themselves as well, and back and forth between them. It's a very different architecture than what we typically think of in Hadoop. And also remember that it's largely done in memory, so this kind of gets you kind of the main pieces of it, like where you have the executor, and the executor contains cache and tasks, and that's all part of a worker node. So that's kind of the hierarchy. I think this diagram came straight from Apache's website, which is kind of a nifty little thing. So we've talked a little bit about Cloudera and Impala. We'll kind of go beyond this. Pigpen is by Netflix, by the way. It's their own little adaptation to Pig. Some organizations really fall in love with Pig. I know Sears did originally when they migrated from their big mainframes. Personally, it's a really neat way to do a lot of aggregation, is what I've noticed. I like it myself. I'm not as experienced with it yet, but I will say that if I was going to do a big batch processing job, I would look seriously at Pig as a way to go. So that's just another thing to look at when you're thinking about these. So Facebook and Presto, Facebook invented their own thing as well when it came to MapReduce lists programs that don't require MapReduce. So now we're in this kind of provisioning step that we're doing now. By the way, I will export this out to a PDF and provide it to our team to make it available. So, we have links and whatnot in here that you can leverage. So let's go see if we're getting any closer. It must be very slow today because I did the same one earlier and it was done in about 5 minutes. We'll keep working through it here. Let's see. We'll come back to these. One thing I want to talk a little bit about too are all kinds of free data sources, right? That when we start playing with big data, sometimes the problems that most people seem to have are, where am I going to get data that's big enough to actually try things out? So I found a couple of public data sources. I'm always on the hunt for public data sources where you can download a bunch of free data, put it on a cluster, drive it around and test it, and see if it works for you. Now the first one is a whole bunch of hard drive test data, which I found really fascinating. It starts to speak to the mean time between failure rates and all the other stuff that we've talked about all these years. And we also have the New York City cab fare data, where I've got all of the information for 2012 only. But I believe, let's take a real quick look at that and see if they've updated it. This has been a month or two since I looked at it. I'll go grab this. I know I'm starting to see some of these show up. When I originally found these, were brand new, and now I'm starting to occasionally see them in other people's demos too. Let's see, it's the trip record data is what we're talking about. Yep. So now we have 13 and 14 out there as well. So, so if you want, this is a great bit of data to help you start to do this analysis. And part of why I was really interested in this one was I worked with one of my teammates, Ginger Grant. She works a lot with Azure ML. And we were trying to come up with some interesting, fun data sets to play with. And this was, I remember, one of them we developed for her. Let's go back here. The hard drive failure one, where we're waiting on our cluster to build. So hard drive reliability statistics. So these are, like, here's Q2 for 2016. So these are some really big stats that you can enjoy. So if you're looking for things to play in some of this arena, some of these are good. There's also data.gov, if you've ever been here. It's an enormous amount of free data from the federal government. So you can look at everything in all these areas, agriculture to healthcare to manufacturing, oceans, everything. So it's kind of moved by the governments, I'm saying, local governments and federal government and whatnot, to kind of expose some of this data to data scientists of every stripe, including we that are just amateur data scientists. And so making this available, you might come up with some really fun insights, and I think that was the purpose. But here are the number of data sets. We're almost up to, we're approaching under 90,000 data sets. So there's just all kinds of stuff to research in here. So between these three, I think you can stay really busy. Let's see, are we any closer? Still not. All right. Should have done it bake-off style. Note to self. All right. Here. So let's talk a minute about RDDs, resilient distributed data sets. They're fault tolerant, and that's really important. You know, if you have a really large computation going on involving Spark, it's safe to say that provided you've got at least, you know, say minimum 3 data nodes out there, that you'll probably be able to withstand a complete failure of one of them and be able to run on 2. If it got down to just 2 versus 1, I'm not sure if that would actually complete. It might, but it might be a very long wait. So, but I would say from my observation, it seems like about 3 data nodes is about what you need minimum to do this stuff. They don't have to be big and beefy. They just have to have plenty of memory. So we have 2 types of transactions. We have transformations, which creates a new data set from an existing one. And of course, they're lazy. They're executed until they're not executed until you execute an action. And then actions return a value to a driver program after running a computation. So that's kind of it on the RDD side. Data frames are another piece, used heavily in R. And it presents basically a kind of a 2-dimensional array-like structure. Think of it as a table. It's possible to convert these things back and forth. And really, in the R areas, I've noticed that they're the ones that really seem to need this. Well, Spark seems to do well providing this area, as mentioned. So, it used to be, up to very recently, we could get to the Scala interface pretty easily from within our HDInsight clusters. I noticed that earlier I didn't see it, so we'll check for it again. But Scala is what all this is really based on, and so if it's there, we'll do a couple demos with it when it completes. And then, of course, the Jupyter notebooks, which I mentioned. All right, let's go back here. Hopefully we're getting somewhere with this. Not so far. Well, I don't know why it's taking so long for that to deploy this suddenly, but we can, we're kind of running out of time here. We could go ahead and take questions in the meantime. If at all possible, I'll do my best to answer them for you while we wait for this to continue.
Sure. Someone wants to know about Apache Drill.
Apache Drill, I'm not familiar with it yet. I do know it's just another framework, but I haven't used it, so I couldn't really speak about that other than to say, you know, there's a lot of public information on it. I would take a look at it, particularly on the Apache website.
Okay. I know the answer to this one, but I'll let you answer it. Someone wants to know if you're doing any SQL Saturdays for big data in the Twin Cities that they can attend.
Actually, yeah. I've actually submitted a couple of proposals to SQL Saturday, Minnesota. I think it's on October the 1st.
It is.
I believe we have one on Apache Spark. I will check that. Actually, we can go do it right now.
I believe you did, but they haven't put up the schedule or anything yet.
Yeah, that's the problem. We're all kind of waiting to see what's going to be accepted. So, all right, we can move on from that then. But if you keep checking back on the schedule on the site. I did submit one, and it's one I'm looking forward to too.
Someone wants to know if Spark is a replacement for MR.
I think that it kind of is. You know, it depends on who you talk to. I follow Cloudera pretty closely because I spend a lot of time on their products. Their theory is that it's a direct replacement for MR.
What is the future of Java in the big data field?
You know, it's kind of like the fundamental building block of all of this stuff. I think that it's going to be around a very long time. I don't think it'll go away. I think it's going to continue to change, though, and evolve. But I do think that there'll always be in somewhere lurking in all of these big clusters. There's going to be Java out there that drives some piece of it. What that's going to be in the future, it would be hard to say. But, I mean, it's hard to take something that was built fundamentally in Java and then throw that away. So.
In your first couple of slides, it was mentioned that Spark is for the Hadoop platform, but then it was mentioned that it is a MapReduce free. So why does it need Hadoop?
You know, I don't think it does. In fact, I think some people have figured out you can run Spark locally on a desktop. In the context in my world, it always goes hand in hand because of just the way my mind thinks and my experience is. But I know of people that are working on like even desktop versions of Spark. So yeah, that's kind of misstated. That's my fault.
Can you share with us the timings when it is scheduled? And someone just wants to know if we can share when your SQL Saturday sessions are posted. I would just say go to the SQL Saturday site. They probably will release it no later than a month out. But just go ahead and check that schedule for SQL Saturday Minnesota on October 1st, and you'll see. But his session will, at least one of your sessions will definitely be picked up, so stay tuned for that. Does functional programming like Scala take over Java in the future?
Take over Java? No, I wouldn't say so because there's such different things. I mean, of course, you know, Java is a big topic. I mean, it's an ocean. Scala is a very narrow topic and very much focused at statistical analysis. No, I think they're on different tracks. I don't see one overtaking the other.
Okay. Hive SQL versus Spark SQL, which one is better?
Hive SQL versus Spark SQL. You know, I don't think there is a Spark SQL, so I must have steered somebody the wrong area. There's Hive, there's Pig, there's all these there's these things that'll all take advantage of Spark, but I don't know that that you could say that there's a Spark SQL. So I think I've probably miscommunicated. Look at it as kind of the way the work gets done underneath. Like we were just talking a few minutes ago about MapReduce and all that, and how that's being replaced by Spark. And Spark, remember, Spark is an in-memory framework, right? So just keep that in somewhere in your mind's eye vision of how this works. So it's a framework, and it works in memory. So it doesn't really have the tools that you might be thinking.
Okay.
Okay.
That was the last one for now.
All right, let's go see if we got anywhere. Did we finish? Did we finish? I think we did. I think we did. Look at this. Holy moly. So we will get a little FaceTime with us. And then it succeeded. So here is our cluster, our GSpark class right here. So working with this is a little different, right? And if any of you have tried this, you kind of know that, you know, it can get really wonky here. So let's see here. What lies should I tell people? Here, I think it's just RGadmin, and it was password, I think, for this guy up here. Womp womp. Just a minute here. It should have worked. Secure shell. So it should go. Let's try that again. Oh, yeah, that's kind of the unfun part of this one. Whenever I get to a place where you get it wrong, it just will not let go of that. Let's see here. It's like Firefox is still trying to run. Now it's going. Let's go back out here to our friend Azure Portal. All right. Let's move here. Here's our Spark class cluster. Let's try this Embari view again. I tried to, let's just see here. Yeah. All right, well, we got 4 minutes left, and I don't know what's wrong with it. Tried the obvious thing, so we'll try it one more time, and if it doesn't work, we'll call it a day. But basically, setting up the cluster is pretty trivial. One thing I can tell you is I set this up in the Linux world. You could have also not long ago been able to do it with the Windows world. So let's see. Let's go back here real quick. And in the Windows world, it had its warts, but it basically did work. I don't know if they're going to bring that back or not. Let's try it one more time here. All right. See, let's try this guy, and we'll drive to it this way. Let's try to get to the Jupyter notebook and see if that'll work. Rats. You can tell I've done this a time or two. That should be it. Just try one more time just to be sure. I think we're going to get it. So luckily, we have PySpark and Scala in the Jupyter notebooks. Let's just try this first one. I was out there driving this around a little earlier this morning just to see, what kind of pre-canned demos they've got set up for you. So if you want to, you can take a look at this guy. I'm just trying the very first demo. So here it talks about Spark context, Hive context, and you can run Shift-Enter to make any of these work. So if I wanted to go in here and load this, I can do Shift-Enter. That'll run it. And you'll notice that below it says, I'm going to go just use my little handy-dandy tool here for a second. It just did this. It's kind of subtle because it's white on, it's black letters on a white background, so it's kind of confusing if you didn't really see it do it. So as you go through here, you can try each of these. If you just highlight this section and do Control-Enter, it will map these, Shift-Enter rather. And same thing here, Shift-Enter. It's basically loading all these up, setting up all the program. Yellow things, I like that. Yellow things is something I would have written. And as you go through this, and then it starts talking about RDD and actions here, right? So you're going to make an array. Big surprise, right? We're talking about RDD again. And we're thinking of arrays. So here's what it looks like, and here's what it is in memory. Here are the number that it found in the RDD. anyway, you get the picture, and I don't want to keep everybody past their time, but there's a lot to learn in this area, and there's some really nice demos, at least for a guy like me that is just curious about these things. So, okay, run out there and set up a cluster, give it a try. That's all I have, Liz.
Great. Thanks, Roland. Thanks, everybody, for joining us today. As always, you'll receive an email tomorrow with a link to the recording. If you have any questions that you didn't get a chance to ask, you can email me, Liz. It's the email that comes with all your GoToWebinar information, and I'll be happy to pass those along. And as always, thanks for joining us, and we hope to see you in another session. Thanks, Roland.
You bet. Bye.